Yeah, welcome to second link session course system design through Verilog. So if you have any queries, quickly ask because the time is limited. Good afternoon. Eligibility criteria is you have to appear for the exam and you have to secure some, I think some 40% of the marks, and you will get the certificate. I don't remember the exact criteria actually. This you can ask to NPTEL either Chennai office or otherwise you can ask to Kallal Barwa of IIT Guwahati. Because these are some administrative issues. This is not technical one. So this section is basically for technical. Basically, you'll be given a code and you have to just decode the program. Then you have to draw the circuit diagram. Once if you know the circuit diagram, then it's just only digital logic design only. You apply the different inputs, you find out the output. So the very first step is you have to just convert this program into the digital circuit. Once if the digital circuit is derived, then you can apply the different inputs. Normally the questions will be on if you give different for a given combinations of the input, you'll be asked to find out the output and what is the function of the circuit and that. Logic level or gate level is very easy. Actually, gate level if we mentioning about the AND or everything. Data flow you have to be aware of. You have to be aware of this assign sequential. These different, these commands are there. That commands actually you have to be familiar. Unary operator for the OR operation, XOR, and once if you get the circuit diagram, then you can easily answer the questions.
Excuse me, sir.
Yes.
So suppose we are given with the expression in the data flow modeling. So how to decode, like we have to check the expression that the expression is correct or not for the given circuit. So what will be the inputs we have to add, like
Sorry.
all ones or all zeros?
All?
So
Can you
all
repeat the
ones
question?
yeah,
Your
sir.
voice is not clear.
Okay. So I am
Can you
saying is
repeat?
that if there is a expression and we have to uh, uh, check its we have to verify it.
Expression is given, then expression you can decode into the circuit diagram, right?
Yeah, sir. So for different inputs, sir, what will be the inputs? We will add all the inputs of the truth table, or they are all ones or all zeros?
Now, most of the questions we are giving some standard circuits like 3 to 8 decoder, JK flip-flop, SR flip-flop, otherwise the counter. In most of the questions, we are giving the code for the standard circuits such as decoder, multiplexer, and all. Once if you find that the program is for decoder, then you can easily answer the questions for the decoder. If the first input is 1, say 0, 0, Y0 is 1, 0, 1, Y1 is 1, and so on.
So we have to check for all the inputs.
Normally in the question, we'll ask for only one combination of the inputs. If it is 3 to 8 decoder, we'll be given the code of 3 to 8 decoder. For A
Yes,
is
sir.
equal to 0, B is equal to 1, C is equal to 0, what will be the outputs? Y0 to Y7.
Yes, sir.
That will be one question. And the second question is again another combination.
Yes, sir. Sorry.
So there may be multiple questions. So if a program is given for one combination of A, B, C, you will be asked to find out the outputs. That will be the first question. So under the same common data, we will have multiple questions. When in the final exam also, the pattern is like this only. So you will be given the code, but they will be asked to find out the output corresponding to A is equal to something, B is equal to something, C is equal to something. In the next question, we will be given some other combinations of A, B, C, or sometimes you will be asked to find out what is the operation that will be performed by this circuit. These types of questions will be.
Okay, sir.
If you clearly follow my lectures, actually I have first discussed about the combinational, sequential circuits. Then I wrote the code corresponding to that combination sequential circuits. So most of the questions are basically on this combinational sequential circuits which I have covered in the lectures.
Okay.
Actually, I don't remember these questions and all. Can you send that question from Q6? First question. Because I don't have the questions now. The final examination questions are exactly similar to the assignment questions. I think some 10% questions are same as assignment, maybe with slight changes. But overall, the paper will be exactly similar to the questions appeared in the assignments. This is basically a implementation of the sum output of a full adder using multiplexer. This question, first question corresponding. Consider this is equal to S1, S0. Basically, we have three multiplexers. I0, I1. Signal and control signal. So for the first multiplexer, it is given that S1, if it is true, S not DC, but if it is false, S not AB. In one case, S not AB, in another case, S not DC. See S not, both the cases. This is for I0, AB, DC.
Excuse me, sir.
Yes.
Sir, the main screen is not presenting. It is
Sir,
blank.
oh, it's not there. I have to share it. Now is it appearing?
Yes, sir.
See just one basically. And then you are given the full adder with the PQR as the inputs and sum is the output. So 0, 0, 0, sum is 0, 0, 0, 1, sum is 1, 0, 1, 0 also sum is 1, 0, 1, 1, sum is 0, 1, 0, 0, sum is 0, 1, 0, 1, sum is 0, 6, 1. 1, 0, 1, 1 plus 0 plus 0 is sum is 0, sum is 1, carry is 0. This is sum is 0, carry is 1. 1, 1, 0 also, sum is 0. 1, 1, 1, sum is 1, carry is 1.
So the truth table is of full adder.
Sorry?
The truth
Full,
table is
fully
of...
added.
Okay, okay.
Here, the given problem is fully added only, na? Full subtracted.
Yes, yes.
So basically here I want the sum. Then what should be this A, B, C, D? This is basically implementation of a 4x1 multiplexer using two 2x1 multiplexers. If you write this as equivalent, this is equivalent to 4x1 multiplexer. I0, I1, I2, I2. And there will be two control signals. This is S1, S0. And here I want the sum. So here in sum, what are the min terms sigma m? This min term is 1, 2, 4, 7. 1, 2, 4, 7. So now to find out the values of I0, I1, I2, I3, we write this I0, I1, I2, I3. And if I connect out of this PQR, we can connect in any way. So in the given problem, you can see whether PQR connected or QR is connected. If QR is connected, then P is left, P bar and P. So in the first four min terms, this is 0, 1, 2, 3, 4, 5, 6, 7. Out of these min terms, so in the first four min terms, P is 0. The next four min terms, P is 1. So P bar means 0, 1, 2, 3. P is 4, 5, 6, 7. Out of these min terms, what are the min terms that are present in the given sum function? Sum function is having 1, 2, 4, 7. To round this 1, 2, 4, 7. Now I0 value will be, if upper one is rounded, then P bar, because lower one is rounded, this is P. So I0 is basically P. And this upper one is rounded, this is P bar. Here also upper one, P bar. This lower one, this is P. So like that, you can find out these values. So if you decode this problem, basically this is implementation of one sum using 4x1 multiplexer, but the 4x1 multiplexer is not directly given. That is the twist here. There is a twist here, which is this instead of giving the 4x1 multiplexer, you have given the implementation of 4x1 multiplexer using three 2x1 multiplexers. We'll be able to this type of theory I have already taught in the lectures. How to implement the larger multiplexer in terms of the smaller. So in the given problem, actually, this is implementation of 4x1 using three 2x1 multiplexers. Then if you write down the equivalent circuit, then the values of the inputs of the 4x1 multiplexer can be found out by using this table. So I0, I1, I2, I3 are A, B, C, D is already assigned. So accordingly, you can find out PR, P bar. See the procedure, correct solution you can do in a similar manner because I have given just the general the theory to solve this problem. Exactly what is A, what is B, these things you can find out from the problem. Initial and final normally will be used to define the initial conditions. Say D flip flop is there initially, the output is 0 or 1. So some initial conditions, because for the circuit operation we need some initial conditions. Normally the initial conditions will be specified by using the initial and final. Exactly similar to the assignment questions only, with little changes. Some minor changes are there. Same as it is, some assignment questions are taken, and some little changes has been made in the questions. If you properly solve these assignment questions, then you can easily answer the final examination questions. This is not the SR flip flop. You can say this is multiplexer, implementation of the sum output using the multiplexer. This output, assign output y is equal to s1 dash. Some two values are given. If s1 is true, the first one will be executed. If s1 is false, second one is executed. Again in s0, s0 is true, d will be the output. S0 is false, c will be the output. Like that, this is multiplexer basically. But instead of giving the 4-by-1 multiplexer, implementation of the 4-by-1 multiplexer by 3 2-by-1 multiplexers was specified by this assign statement. That is the only logic in this problem. But it is not SR flip flop. Thank you for your wishes. Any more queries, please quickly ask. Because the time is limited.
So what is the purpose of flower brackets in the data flow modeling?
So basically, this problem is somewhat tedious problem only. Usually do this type of the problems I have discussed in the class also. Well, the design of sequential circuits, it's given that there are two SR flip-flops. One output is CC bar. We have the inputs. F0 say F1 S1 R1. Output says given as DD bar, right? So it's given that SR flip-flop whose outputs are C and D and two inputs AB. If A is equal to 0, circuit remains in the same state. So C and D, D and D1. And in addition to this, there are two more inputs, A and B. In addition to this SR inputs, there are two more external inputs, A and B. Now the status is present state and next state. We find out the present state. The CD. C is the output of this flip-flop, D is the output of this flip. And next state. This next state depends upon the AB. CD. If AB is equal to 0, 0. What happens is given that if this is 0, 0, this is also 0, no change. 0, 0, 0, 1. 0, 1, 0, 1. 1, 0, 1, 0. 1, 1, 1, 1. Then if I take the second column here, the AB is 0, 1. Then it's given that A is equal to 1, B is equal to 1. Circuit goes through the transition 0, 0 to 0, 1, 0, 1 to 1, 0, and then back to this is 1, 1. One zero, left 0, 0. So in A is equal to 0, in both these cases, AB is equal to 0, 0, or AB is equal to 0, 1 also. The same states will be there. Because given that if A is equal to 0, simply the circuit remains in the same state. 0, 0 to 0, 0, 0, 1 to 0, 1, 1, 0 to 1, 0, 1, 1 to 1. And the other two states A, B is equal to 1, 0 and 1, 1. Given different states, like if A, B is equal to 1, 1, it is given that previous value of CD, previous present state, next state of CD. If this is 0, 0, it's given that it will be 0, 1. If it is 0, 1, 1, 0. If it is 1, 0, 1, 1. If it is 1, 1, 0, 0. And similarly for the other combination AB is equal to 1, 0. It is given some state in the problem CD. So basically now you will get total 4 inputs. This AB is having 4 different values and CD different combinations. So we can find out now A, B, C, D. This is present state. So what is the next state? CD. This is 0, 0, 0, 0, 0, 0, 0, 0. This is 0, 0 is 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1. Similarly for the next combinations, this is 0, 1. If I fix AB to 0, 1, then output remains in the same previous state. For 1, 0, it has given some state. 1, 1, this is the change of the states. Like that, you can make 16 combinations total. Then you can write down the expression for this next state as a function of A, B, and C, D. So the next state of this flip-flops depends upon this CD as well as this AB. Once if you know this next state, then to come from this present state to next state, what are the flip-flop input functions? What is the input S0 and R0 required so that C has to remain in 0, D has to remain in 0. So you can concurrent is basically to join the smaller numbers into a bigger number. This concurrent operation was explained in the lectures. You can just refer the lectures here. Here I have explained with examples also.
Excuse me, sir.
Yes, please.
Sir, can you please guide me that I have missed 3 weeks videos. So can I be able to gather it up?
They are all in the online. Na? If you go to the IIT Guwahati YouTube channel, you can download all the videos. This main course, I thought I think 2 3 years back. So already all the
Okay, sir.
yeah, sorry, there was network issue. Yeah, 10 minutes is left. Please quickly ask the questions if any.
So I want to ask you from the lecture counters that why do we convert the T flip-flop to D flip-flop? Then,
Why?
so why we converted the wait, sir, wait.
Actually, that conversion, if it is given to design using the D flip flop, then you know convert. Otherwise, no need.
Okay, okay, sir.
The thing is, if you want to design the D or T flip flop, only one input is required, so complexity is less.
Okay, sir. Sir, is hash symbol is used for comments?
Comments in the code.
Yes, sir. You have used hash symbol.
Hash symbol is for delay.
Okay. Sir, in the video lecture you had written so.
This is a double slash will be for the comments at the end of this code. And before the code, if you write a hash symbol, then that is delay.
Delay.
Yeah. Any questions, class?
Excuse me, sir.
Yes.
So in the sequential detector lecture, so why you have used the combinational circuit?
Combinational logic is basically all the circuitry which is outside the flip-flops. You have some flip-flops. In addition to that, you will be having some logic gates. That logic gates all together is called combination circuit.
Oh, okay, sir.
Yeah, any more questions? Only 2-3 minutes left. C is basically a non-blocking statement. D will be assigned to the Q. So whenever you start the program, so all the statements which will be written by using this less than or equal to type of the symbol. then all those operations will be performed simultaneously. In case of blocking statements, after the execution of the first statement only, we can execute the second one. After the second, third. Whereas in non-blocking, we can execute parallelly more than one statements also. So this is less than or equal to symbol is basically like this, and D we are assuming to Q. Because in D flip-flop, basically output is equal to input. Suppose I'm applying the clock signal, whatever the input will be transferred to the output, basically. So Q is the output and D is the input. So for D flip-flop, output is equal to input.
Sir, although it is only one line, so blocking statement can also be implemented.
Blocking statement will be is equal to will be there. The left hand side variable and right hand side variable will be equated by using is equal to symbol. Whereas it is less than or equal to this, it is non-blocking. So all those statements will be performed parallelly. If it is equal to, then one after the other will be performed in a sequential manner. Yeah, it's already 4 o'clock, and thank you for your active participation. Thank you. Good luck for final exam.
Thank you, sir.
Thank you.